Hello everyone, welcome back to my channel. Today we'll be starting off with ellipse drawing algorithm, midpoint ellipse drawing algorithm, and it will be similar to the midpoint circle drawing algorithm as well. In the sense that in midpoint circle drawing algorithm we just used 8-way symmetry because we first calculate this one of the zones, and then after that we can just translate the x and y values accordingly and calculate the points for the other zone as well. Now for the midpoint ellipse algorithm, it's a bit complex in the sense that we use 4-way symmetry instead of 8-way symmetry, and we divide each quadrant to 2 regions. That's just how the rule goes. So first we'll be calculating for this last quadrant, the 4th quadrant, and if we can calculate for this quadrant the values, then we can easily calculate for the other quadrants depending on where the ellipse is drawn. Alright, so for region 1 we choose east and southeast region. Here I've computed the values. The general equation that we use for this algorithm is this one. This is the general equation that we use. This is a bit more complex equation compared to the other ones, in the sense that it will take a bit of time to calculate, to derive the values for the east and southeast region. Therefore, we just plug in the values as usual. Here we'll first take the d. Let's just find out d initial for region 1, and for region 1 the midpoint is over here. So x plus 1, y minus half. So these are the coordinates, and we'll use the coordinates from the circle algorithm that we used, x equals to 0 and y equals to b minus half in this case, because y is the first y coordinate is essentially b. That's according to the algorithm, and for the initial x, then so the initial x value is 0 and the initial y value is b. So we plug in the values to this equation and we get this. We're left with this equation. First we plug in these coordinates to here, and then we plug in these coordinates of x equals to 0, which is 1, so the coordinate becomes 1, and y equals to b, so b minus half. Let me just write down here. Plus 1 equals 1 and y equals b minus half, and after that we derive this equation. Again, same way as we have done with all the other algorithms. First we find the fm1 minus fm. Here fm1 minus fm, let me just take this, fm1 minus fm, this is for del e, and fm1 the coordinate is x plus 2 y minus half. Here it's written x plus 2 y minus half, and the midpoint one is x plus 1 y minus half. Then again we plug in the values like so in the general equation, and we are left with this. And remember, the general equation always equates to 0. Alright, so in the east region, of course, only the x coordinate will increase, and for the southeast region, x coordinate increases and y coordinate decreases. X coordinate increases, y coordinate decreases. Alright, and east is taken as the negative region, and southeast is taken as the positive region, the positive portion. Alright, after this is calculated, when do we switch to region 2? We switch to region 2 when we reach the border boundary, which is this gradient, and this gradient is always, the slope is always -1. So when do we reach this? When essentially the j, like think of it as a vector system, like so. So like when j is greater than I, then we switch to this region. This is region 1 and this is region 2. So when the j vector is going to be higher than I vector, we switch to region 2. We like, if you just translate it over a coordinate system like this, then that's how you can understand which is greater and which is smaller. So the j coordinate is a square into y minus half. Why this? Because this is the midpoint of region 1, x plus 1 y minus half. So when b square into x plus 1 is less than a square into a y minus half, that is when this j coordinate j vector is greater than I vector, then we switch from region 1 to region 2. So let me just point it here. This is region 1, this is region 2. Okay, so we switch that way when this is greater than this. That's according to the algorithm. Now we compute for region 2. For region 2 we'll have another 2 sets of equations. So first we find d initial, which is the midpoint for region 2 is x plus half y minus 1. and we plug in the values, and then we get this equation for the D initial. Same way we can calculate the values for SE as well. So FM3 minus excuse my crappy handwriting, so FM3 minus FM4, then we plug in the values as usual, and for del S is FM5 minus FM4. Also for in this case, SE is taken as negative and S is taken as positive. Alright, so that's how the ellipse drawing algorithm goes. You just derive the values and again just compute and just add this with the D initial. So like if E is negative and SE is positive, when the D value is negative, we just add D plus D equals D plus B square into 2x B square into 2x plus 3, and when D is positive, we just add D equals D plus B square into, this whole equation, we just add this. Alright, so and then the same way we do the same technique here, and that is how you compute the whole ellipse drawing tracing. That's how you find out the x and y values for drawing an ellipse. So that's all for ellipse drawing algorithm. Next up we'll be starting with line clipping algorithm, so stay tuned.